Today we're going to talk about life after Selenium. And a little bit about me. I've been doing UI testing since 2014. It's all I really know. I've done some API testing, system and performance testing, but UI is really what I love. I always end up on the UI team for whatever company I work at. But I just want to be clear that I don't work for Cypress. I don't work for any of these companies. But in this talk, what we're going to talk about today, it's some really exciting stuff. We're going to talk about Selenium and browsers and what that kind of means. We're going to talk about the inherent problems with Selenium. We will ride the wave and see what that kind of means with respect to Selenium and Chrome. Talk about some of the new solutions out there. So we're not going to just talk about Cypress today. We're going to walk through the same test and 3 frameworks, and then take a minute to talk about, what kind of happens next, and I'll make sure to leave some time for Q&A at the end. Great. Okay. All right. So, but in this meeting, I am not going to convince you to delete and restart. I'm not being paid. At least I don't think so. We're not going to talk about mobile. We'll just pretend that doesn't exist for now. We're not going to talk about every alternative out there, and we're not going to talk about Python and Java. We're just going to keep this to JavaScript. So at a high level, Selenium, what is it? We all know, I think we all know what it is by now. It's the de facto open source UI testing tool to automate browser interactions for web applications. So let's just pick that apart just a little bit. Automating browser interactions. So what Selenium is doing under the hood is driving a browser, checking what's going on in that browser to verify your web application, the system under test, the application under test. It was created in 2004, maintained by the Selenium HQ company now, or project now. And just to be clear, Selenium now refers to the infrastructure and tooling to run WebDriver. And WebDriver is now part of the W3C browser specification. So that happened recently. And that means it's cross-browser by definition. That means that if you're using a web browser, that it has native bindings to work with Selenium or work with WebDriver. So it's a really huge accomplishment for UI testers. It's huge. That can't be overstated. Let's just lift the hood a little bit and see what it looks like. So left to right, you have your client libraries, the things that you use to talk to your web application with. That communicates via JSON wire to WebDriver. That WebDriver can be, depending if it's Chrome, it'll be Chrome driver, Gecko for Firefox. You'll have different drivers that all use this W3C specification I was talking about earlier to do a RESTful HTTP request to a browser, a real browser that then communicates to your web app via, REST HTTP or WebSocket. But so left to right, you have your client library. So if it's Python, you have PyTest communicating to WebDriver through a stateless interaction to your browser, to your web app. So that's kind of the diagram, but what does this solve? That doesn't really translate to anything. So what this solved is it gave us testability for web browsers. It gave us a way to communicate with web browsers. It was open source. So in the dark era, the dark days, everything was QTP based or some other solution that you had to pay for. And it wasn't, if the browser changed, you were completely and totally dependent and in the dark for that tooling to change with it. It basically standardized interactions for all browsers via the W3C WebDriver spec. It provides, language bindings to interact with a WebDriver. And as we said earlier, Selenium itself provides the infrastructure and tooling. But what is WebDriver driving? Well, web drivers are driving ultimately a web browser, and a web browser serves up the web application, the thing that you and I really care about. And that web browser does a few things. In the context of today, we're going to talk about XHR requests, the DOM, and events. So a browser sends and receives AJAX or XHR requests to a backend. Now that could be GraphQL, that could be a WebSocket, but more than likely it's a REST API. that data constructs the DOM, or the structure of what you see on the screen. What the DOM is the document object model that actually describes what Selenium ultimately is going to interact with, like the button that it exists, where it exists. And the browser also handles changes with W3C events. So that's the W3C WebDriver API spec. So the DOM being loaded or somebody clicking, that's all handled by the web browser in a standard way with an API. But enough talking. Let's just take a look here. So let's take a look at the what I have running in the background is the Cypress real world app that they keep. It's great. And just to give you a little bit of a tour here, it's got a login page we all know and love. It basically allows you to look at transaction as if this were a banking app. But what we're going to look at today is a few things. We're going to look at clicking on this button after logging in. We're going to look at typing in. We want this last one here. We want to look at Davon Becker. That's what we want. So to do that, what that actually looks like, let's just briefly talk about those XHR and DOM and events really quick. So if I pull up the Chrome DevTools, I'm going to pull it up here. The Chrome DevTools gives you a view of the things that are going on within the application. So I'm going to record the page, going to refresh, and let's see what happens. I refresh the page, and we can stop profiling. So this is a live demo. Hopefully this works. Okay, so it's processing. Great. So what we have here in the Chrome DevTools is everything that just occurred. So here you can see right about here in the live view, you can see that I refresh the page. And if we look at the events that occurred, we can see that the DOM eventually loaded. The DOM contains everything about what the browser needs to know to construct what we see. And we get DOM complete, I believe. Yep, DOM complete. That means that we're done. We loaded everything we needed to load, but that doesn't mean that we have everything that we need to continue. So the other thing that we get here are, and I'll pop out of, because you can't see this, but you can see that there are network requests going here, but it's a little too small. But what's going on in the background is we're making these XHR requests. We're talking to the backend to say, hey, give me this information. And that looks like this. It's a request and a response. We're sending a request to, in this case, transaction public, and we're getting a response or a data structure payload that the browser then knows what to do with. So when let's go ahead and just clear this, and let's click on this and see what happens. So this got a users list, a list of users for us to interact with. And I apologize, I know this is a little too small, but we send off other requests right here. Every single time we interact here, we're getting mouse events, or so we're getting events that are happening, but more importantly, we're getting requests and responses from the API from the perspective of the browser. Again, this is the Chrome DevTools. This is what Chrome sees when it's interacting with the web application. So I'll go ahead and stop there. And what I'm going to do is I'm going to pull up a Selenium WebDriver test. So I've attached to this meeting, there's a GitHub. You can go and see and play around with this. So I have a test here. Let me pull the slides back up. Let's see. And so what we're going to do is we're going to write a test. Unfortunately, just due to speed, it's already written just because of, we only have 50 minutes together. Launch Chrome, navigate to the WRA real world app, check the title of the page, log in by filling in the username and password, which we did, and clicking the login button. Then finding this button, remember the new button, clicking it, and then searching for Davon Becker like we did, and verifying the result. Again, remember the XHR request was this query here. So let's go ahead and do that. So let me pull up the Selenium test. So this is just a run of your mill Selenium. So we instantiate the WebDriver, which pulls up a browser. We navigate or visit localhost 3000 where this is running. We get the title and we assert that the title equals React app. Then we do a series of steps here to log in and navigate to the new transaction page. All here, you can see the structure. We find the element, we send the keys, and we find this element and we click. And then we are going to find in this case, we're going to find that new button and click on it. And then the final test is going to be sending the query and verifying that we get this response back. And so just the general flow again is logging in or instantiating a browser, navigating, checking the title, clicking the submit button, and then typing in Dave von Becker. So that's the overall flow. So let's go ahead and give this a shot. So if you pull that up, you can go to, let's see, npm run test Selenium. And so you can see it launched Chrome, logged in, but oh no, it failed. So let's see. So it says that no such element existed for this here. So that's odd. We don't exactly know why that is. We have this console log that kind of helps us, but we're kind of stuck at this point. So I'm actually going to leave you all in suspense and move on, and we're going to come back and fix this test. But what we just saw was, you know, we inherently have problems with Selenium, and we're going to talk about them. But in a review of the browsers, you get the DOM loading event, you fire off XHR requests, the API returns a response, you get a mouse, the DOM loaded mouse click events, and the browser renders and repaints based off of that return or those individual events. So let's leave ourselves in suspense and talk about the direct problems. Flake. UI testing is considered inherently flaky. It's difficult to understand why a test failed. In our case, we know this. Look at this. We don't know why this test failed. We don't have, we have a console log that kind of tells us, but we don't have any video or screenshots. That would have to be added by a framework. And just to put this into perspective, one of the companies called Sauce Labs considered when they were publishing a report that 3% of all of their Selenium tests will ultimately be flaky or have a reliability baseline of about 3%. This is well understood. It's hard to understand what happens, and it happens a lot. And the reason this is because we are the observers. And we're going to talk about that in a little bit here, but we are observing what's happening from the perspective of the WebDriver talking to the browser, talking to the web app. And so we went over the flaky demo here, but the reason that I wanted to show this is we're talking about this area here. So the reason that we're flaking is that we're not event driven, that we pull for events, first listening for events, and we have a loose coupling between what's occurring on the driver, what's happening within the test itself, what's happening between the browser, and what's happening between the web app. So in our case with WebDriver, we have no concept of what's happening between the web app and the browser. Everything is, we are observing via the stateless REST HTTP response to the browser. So let's talk about how we can fix that. We have this loose coupling. So let's talk about how we can fix that. So let's pop open the, let's pop this test back open. So the first thing we can do, which is what I think a lot of people do, the first anti-pattern is to sleep. So again, so we're going to the login, but let's sleep. And then we will rerun this test. So we are going to wait 2,000 seconds for this to appear, and then bam, we got it. So what's happening here is that there's no concept for this test to know when an element is available. There's no way to know in the perspective of this test that after we click that we actually, that this may not be available. So there's a certain amount of time, there's a certain amount of things, and what those are actually the network requests, the things that are going on in the background. And those are transparent, those are totally opaque to us. Another pattern is to navigate and wait and make assumptions about where the test is based off of elements on the screen. But Selenium does provide a way around this. They provide this waiting mechanism, this method here, that you can wait until an element is located. And you do that by polling the WebDriver for 1,000 seconds. So you poll until true. So let's see if that improves what we're running into here. We're going to poll until that is available. And it works. But if we didn't poll long enough, or we didn't wait long enough, just do 10 milliseconds. We've got problems, the same problem. And so you can see how this kind of changes. So we are waiting, we are polling, we are an observer that never really knows the state that we're in. To quickly go through the rest of the problems, there's a lot to manage here usually. So these are all of the dependencies that we would have to manage by using Selenium. The framework, the language binding, the WebDriver. Remember, we looked at the different ones available depending on the browser type, version, the capabilities. For those of you that have used Selenium, you all know what this is of that browser. It's not truly a W3C specification because not every API is the same. The jar, the JRE, the OS, and the version. Luckily, Docker to the rescue. It solves most of this. Selenium HQ provides this Docker image, which contains most of everything that we need here. And then at the end of the day, you really just have to worry about this test code here. But that has its cost. So it's extremely expensive to run Docker Selenium. If you wanted to add video recording to Selenium, you could use something like a project like Docker Selenium. Igalu is the name of the project. But in order to add VNC recording, you have to add a core and a gigabyte of memory and then don't even talk about storage of all these videos being recorded, just to record a video to understand what's going on. The JMeter example is if you're going to use the JMeter load testing tool to test APIs or basically simulate load or traffic on a website, they provide Selenium bindings for that. But when you're sizing how many resources you're going to need to test, it's a 1,000 to 1 ratio. That is to say, you need to run one Selenium-based JMeter test in the same amount of time and the same amount of resources, you could execute 1,000 API tests. So these are extremely expensive to run, and there's companies out there that'll help. This is Sauce Labs again. If you want to run 24 tests in parallel, Selenium tests, it's going to cost you almost $5,000 a month. The other thing to talk about is everything you just saw is local. What we just showed was local, but Selenium is polling based. It's stateless REST HTTP traffic. And so it's heavily impacted by network latency. And unfortunately, this isn't the one I could reproduce today for you locally. But effectively, I used a chaos engineering tool called Comcast, which allows you to inject network latency in your network or through somewhere on your VM or wherever you want. In this case, I injected latency between the test runner and the browser. So it's basically here and here. And if you were to ping Sauce Labs right now, just ping it, you'd see about 72 milliseconds. Well, let's see what that sort of network latency has in terms of an impact of our performance in our tests. So by just running through this regression test suite I had 0 latency and the test finished under 2 minutes. And when I scaled it up closer to what Sauce Labs adds, 75 milliseconds, the same tests, everything was the same. Everything was the same. The test went from 2 minutes to 5.5 minutes. All we did was just introduce network latency. And the reason that's important is, if you recall, this is stateless. This is network traffic. The distance between any of these components really adds up when you're polling and when you're waiting, and that the duration that you have to wait will go from 10 milliseconds to 10 seconds very, very quickly. Lots of waiting. So just to summarize it all, lots of dependencies, speed and performance. It's expensive to run, or you can pay someone else to run it for you. It's inherently flaky due to the loose coupling between what the state of the browser is based off of the state of the WebDriver. But what we get from this is cross-browser, or so we think. So Selenium is cross-browser. If you wanted to use Testing Bot, which is an alternative to Sauce Labs to run your Selenium tests, they can do it. And there's a lot to test here. There's 2,500 combinations that they provide, depending if you want to be on Windows, Firefox, Chrome, Safari. Every matrix, or everything fits into this matrix that we all have to test. And I'll just move on here. And what are you testing at the end of the day? At the end of the day, when you're doing cross-browser testing, you're just really testing these different rendering engines, the ability for Chrome to render this new button on screen in this way with this color. That's ultimately all that you're testing. And you have three major flavors: WebKit, Blink, and Gecko. Those are the three. You're also, I guess, implicitly testing browser APIs, testing each operating system, but cross-browser testing is basically just the ability for this to render on screen. And that's, I think all of us associate Selenium with cross-browser testing, but what I'm about to talk about is stale. This has been inaccurate in the past because the pace of change, and so this isn't going to be as totally accurate in the future. But what we're going to do is ride the wave and talk about Chrome. So what happened since 2004? 2004, if you recall, is when Selenium was introduced or became a project. Well, Chrome came into the picture, and Chrome does a lot. Chrome did a lot. Chrome is what I'm using right now, and maybe what you're using right now as well. And you can quite clearly see this in the WebDriver usage trends published by the W3C. We have Chrome, and you can see in about 2012 is when Chrome actually outpaced IE and Edge. You can see this, and right now, this is the general state of things. Chrome is at above 60, maybe 70% of all browser usage. Safari's still hanging in there. Opera's in there. Firefox is still holding on, but you can quite clearly see what's happened. And the best example of this change, the best example of cross-browser kind of changing and flipping on its head, is when Edge Chromium, or when the Microsoft Edge team gave up. They stopped making their own rendering engine. It used to be that you would download Microsoft Edge, which is similar to IE, and you would have to worry about this in your compatibility matrix because they had their own engine called Edge HTML. And in late 2018, they announced that they were switching to Chrome. So at this point, the best example of that I have that things are changing is that Microsoft is now using Chromium under the hood. And the only real difference here between Chrome and Chromium is that it doesn't have licensed codecs, so you can't Netflix and chill. But this is really, in my view, the best example of how things are changing. Things are moving away from cross-browser being important because we're actually getting fewer browsers, and there's less variety in general. If you look at this, just generally less variety. The other big thing is browsers are becoming evergreen. So the Chrome browser you're using, the Firefox you're using right now, is actually way more stable than it used to be back in 2004. And the best example of this that I have is, can anyone honestly say what version of Chrome you're on right now? What version of Firefox? You might know because you might have had a recent update, but at the end of the day, you didn't update it. It just updated itself. So things are kind of changing. The wave is basically Chrome is taking over. Browsers are becoming more mature, more stable. Cross-browser testing itself is actually doing less. And due to the nature of the way that JavaScript frameworks are coming into play, things are a little bit more stable, which is a good thing for us. It means that we can make more assumptions. We can do fewer things. And that really comes down to all the last 30 minutes is kind of just leading to this point, which is, what are the solutions? We talked about the problems with Selenium. We talked about how Chrome is changing, how Chrome has changed. Well, what did it do? Well, Chrome added Puppeteer. So the biggest change that's happened recently is Puppeteer. It's how Chrome tests Chrome. So everything that you would want to know, or as a test engineer, about what was going on under the hood with Chrome, if you worked for Google, is now available here in the Chrome DevTools. Well, that's awesome. What does that mean for us? Well, it means that this is now an API. This is now an interface for Chrome via what's called the Chrome DevTools protocol. Anything you would want to know about what's going on in the browser, um, performance-wise, anything you would want to know as someone who is testing Chrome is now made available to you, because with Puppeteer, you're testing Chrome as if you work for Chrome and more work for the Chrome dev team themselves. More importantly, the API is almost an identical match to WebDriver. So they modeled the API after WebDriver, so it looks and feels very much the same. Um, the Also, it's super lightweight. You just npm install Puppeteer, and it brings everything down that you need, including a functional version of Chrome. It's great. It's always working. So if there's a released version of Chrome, then there's a released version of Puppeteer that has a working Chromium binary to work with, which is great. It solves the dependency stack, the mess that we used to have to deal with. Again, npm install Puppeteer is all you need. And so this API that we're talking about, we're going to talk about a little bit more here in a second, Chrome DevTools, used to just be for Chrome, but as of a few months ago, I think maybe 3 months ago now, Firefox actually added support for this API. So Firefox now supports the Chrome DevTools API interface, which is great. This starts to add this cross-browser testing that we would have normally given up on by going with Puppeteer. Now we can test more browsers with this new interface and this new tool called Puppeteer. So Puppeteer is not a framework. The last thing I want to say, it's not a framework. It's just a Selenium replacement. So if you recall, Selenium has this relationship to WebDriver, and that is, it's the infrastructure and tooling necessary to run WebDriver. It's the same here. Puppeteer is the infrastructure and tooling necessary to run against this new API, which is the analog to WebDriver. But that's a lot of words. That's a lot of, but what do we actually get? What's the important part? What are we actually getting from all of this? Well, we're now event driven. So instead of having this RESTful interface that we had to pull against, now we get real-time, instantaneous information about what's going on within the browser. That includes the DOM, that includes everything you would want to know, and anything that you would want to know that would be coming back from the web app. It has a WebSocket interface, so it's streaming information now and not pulling over RESTful HTTP, stateless HTTP requests. So now there's no impact for network latency. The distance between any of your components here has almost no bearing on how quickly your tests run. CDP exposes all these native browser interactions that are totally invisible, totally unavailable to Selenium. So now you can intercept and interact with network calls. Remember, these calls that are coming back from Chrome DevTools are actually available to us to manipulate, because that's something that the Chrome dev team would want. They would want the ability to test those things. So just a quick head-to-head diagram comparison. We have the client libraries on the left, the web applications on the right, but the difference in between is this WebSocket interface with a real Chrome browser getting all information back. There's no Chrome driver or multiple flavors of binaries. This is all absolutely stateless, this is real-time information versus stateless polling. And there's everything that, and this is the kind of the best comparison head-to-head that I can think to draw. I apologize for my drawing skills. But what this gives us is basically real-time instantaneous control of our tests, something that kind of totally removes totally removes all of the problems we once had with UI testing. So just a quick summary. This is what I think this helps kind of bring it all together here. WebDriver and CDP. I need to call it out that the WebDriver is a W3C specification. It works on every browser since 2018 and forever in the future. Well, presumably in the future. CDP is not. It's for Chrome by Chrome. They added Firefox just recently. The interaction is polling versus real time. You're in dependency heck versus heaven. Very little to manage. Cross browser, sort of Firefox and Chrome for now. it's not inherently flaky anymore, which is awesome. And it's super lightweight. So that's Chrome DevTools protocol and Puppeteer. And the best way that I know to illustrate how powerful this change has been, how much this has changed things, is that in March of this year, WebDriver IO, which is an alternative to Cypress or any other JavaScript testing framework, actually stopped using their WebDriver-based solution and started using Puppeteer. So Puppeteer is now the way that WebDriver IO runs your tests. And they even allow you to switch interchangeably. So I'm going to show that off here. So if you had been using WebDriver IO and you want all of these powerful features that come with this new protocol, this new DevTools, you don't have to do anything. You just have to upgrade. So the best way to show this is if you look at the package.json here, I've created two different scripts. We have the WebDriver IO, we have the WebDriver-based solution and the Puppeteer-based solution. The configuration is simply just the DevTools flag that's being sent. And if we look at the test, it actually looks very similar to Selenium because it is using WebDriver under the hood for the test, but also we're going to switch between the two. So just take a brief look at this. And we have something very similar to the Selenium test. We we instantiate the browser. We navigate to the localhost 3000. We wait for the page title, cert equal React app, very similar. We enter in these values and click the button. In this case, we're actually waiting for the button to exist before moving on. And in our case, we're going to execute the WebDriver-based one. I called it Selenium here. Let me WebDriver. So we are going to find the search bar and start entering. And then we are going to wait for the Devon Becker result, just like we did with the Selenium test. So let's save, cross our fingers, see if this works. So instead of that, we are going to do WebDriver IO, and we're going to do WebDriver. So this is WebDriver running. Very similar, instantiating the browser, running the browser, and it failed. So it failed for the same reason that it would fail with Selenium, which is that it doesn't know, it doesn't have the information about this search term being returned. Specifically, it doesn't have the information that we need that this XHR request has been sent and that this XHR request has returned with a 200, for example. So let's fix this test in the same way we would fix any Selenium-based test. Let's just add a wait, pause like we always do. So we're going to pause like we always do. We have the WebDriver running. Waiting, entering, and done. It worked. Yeah, so this is very similar to Selenium. This is WebDriver under the hood, but we can do one better. So I talked about Puppeteer. So what we're going to do is we're going to skip the WebDriver version of this test, and we're going to do something a little bit different. We are going to use Puppeteer to the fullest. Notice how little has actually changed here in the way that this is constructed. Specifically, this line here, it's pattern matching exactly here. But what we're going to do is we're going to intercept the network request. We are going to actually look for this network request that we know is happening on the application and we know the browser is waiting for. We're waiting for a 200 response. So let's do it. Cancel that. All right. So we're launching a Chrome browser again in exactly the same way. This is using Puppeteer under the hood. And we're doing exactly the same tests, but now we're getting the instantaneous results. We are waiting We are waiting for this to come across the wire. Specifically, we expect this request to come across the wire. And then once it does, then we move on in the test. So there's no additional wait. So if this web application was somewhere on the network 100 milliseconds away, the instant that the browser got this request back and got a 200 back, the test would move on. So you can see how this affected that my Comcast related test, where adding in all these weights, adding in all this time really stretched out how long these tests run based off of the network. But now that's gone. Now that as soon as we get that response back from the browser, it moves on with the test, which is great. So now we have tests that are as fast as possible. And we can now start to make assertions here. Look at this. We can start to make assertions here on what the browser is doing, actual native browser events. And so that's really the power of Puppeteer. And that's really what's so awesome about these new tools. And we're going to talk about Cypress next. But we kind of get this new information in ways that we never had before, which are just fundamentally not possible with Selenium. So we're going to just spend half a second on Playwright. Playwright is what happens when Chrome tests Chrome, but Microsoft wants to hire that team. So what Playwright is Playwright is the Puppeteer leads were poached by Microsoft to go make an alternative. And they set out to start from scratch. I'm doing air quotes here. But they are basically doing cross-browser done right. So they've added, before Puppeteer added Firefox, they added Playwright Firefox in addition to Safari. So this is really cool stuff because now you can run Safari on Windows and Linux because you're running the rendering engine on Linux, which is awesome, something that's never been possible before. This is not a total framework. This is literally a direct replacement for Puppeteer. There are even some tools out there that will help you switch between Puppeteer and Playwright in the same way that I just switched between WebDriver and Puppeteer. It's very similar. So let's just take a look at it. It's actually quite boring to look at because it is so similar. But again, it's a direct competitor to Puppeteer, but it's very similar, almost interchangeable with most frameworks. So let's pull out Playwright. So let's look at the test. Very similar. You go to, in this case, we're doing something a little bit more powerful than the other. Instead of waiting for individual XHR requests, you can do something really cool here. You can wait for all network traffic to be idle, which is really powerful. But we're doing all the same tests here. This is really boring now at this point. We're just kind of going through the motions here. I'm going to just take a screenshot here to let you know that it finished. So let's do Playwright test, Playwright multi-browser. So we're going to run one of every browser. Again, the test is really boring at this point. It all looks the same. It all feels the same. And a lot of the language is almost identical. So we're logging in this case, Chrome. Took a screenshot and we're done. Now we're opening, what is this one? This is Firefox, doing the same test. And we're done. Now we're going to do the same thing. Look at this. This is with WebKit, which is Safari's rendering engine. I'm on a Mac, but if you were on a Windows machine, you could run a Safari test on your computer. And that's it. That's the test. Very similar. There's no, as far as I can tell, there's no real reason to use one over the other. It's just picking which you think is going to have a better future with Chrome or with the old Puppeteer team. Very similar, very boring. Not much to add there. But what I want to spend the last bit of our time talking about today is Cypress, what we're all here for. So to do a comparison with Cypress, it's using something that's not exactly CDP. It does use a little bit of CDP under the hood. It's not exactly the same. It does it has more of a proprietary proxy server. It basically will inject something into the Chrome browser to run. It basically will inject the equivalent of WebDriver into the browser, but through that you get everything you would want to see is the same with that you get with Chrome Chrome DevTools protocol. You get all of that information, which is awesome. It's got a freemium OSS model, which allows you to use it. It's open source. Play around with it. If you are an open source project like I am, with AWX at Ansible, you get the capability of getting a lot of these awesome paid for features for your project. It is an all-in-one solution. Same way that you can do npm install Puppeteer, you can do npm install Cypress, and it all comes together. Very few dependencies. It's got a GUI playground to play around with, which is what we're going to look at today. The dashboard service we're going to spend just a minute looking at is what comes with the paid for model, unless you're a open source project, and it's now cross-platform. It works on Firefox. Super cool. So let's, and if you'll forgive me, I need to do this just a little bit different. Let's pull open the test here and look at Cypress. So the test is very similar. We visit the URL. And in this case, we're not going to skip this test. We're going to check the title, but look how clean the syntax is. We are going to get these elements, type in these username and password, click. We are going to note that we're waiting for that, the new button to appear. We're implicitly waiting before clicking on it. And instead of waiting altogether, we're going to instantiate a server intercept. We're going to look for, remember, this XHR request. Once we get that back, we are going to alias it as Devon search. So we'll begin the rest of the test at this point by searching, typing and searching. But before continuing, we're going to wait on this network request to come back before moving on. So this gives us what we saw with Puppeteer, all the ability to kind of wait and before moving on, getting rid of all the flakiness that we were talking about. So let me save this and do npx Cypress open. And so you can see here, browser, or this is a nice little GUI playground that lets you see all the tests. In our case, we're going to look at the same test we saw in VS Code. And this is going to open Chrome, but it's going to do something a little bit different for those of you that have not seen Cypress before. It's going to create this iframe, which is a record of everything going on in the test. And through this, we're actually going to see, I did not skip the other tests, sorry. We're just going to focus on this first test before moving on to the second test. But you can see you get DOM snapshots. Remember, we talked about having access to the DOM. What that kind of gives it, well, what you get is you get to see everything that the browser sees here, and you get a snapshot of what it looked like before and after. You get to see exactly where the browser was told to click and what happened afterwards. Awesome. All of this information is made available to the test, and all of this information is made available to you, the person that's looking at your test. And you can even see, look in the background here, you can see the XHR requests as they go across. So we have a get on all of these. In our case, remember, we're waiting for this XHR to come back before continuing, and that ensures that our test is not flaky. It ensures that we don't have to add in all these explicit waits all of this time. It just ensures that the test works, and it always works. It always works this way. But let me show you one last thing. Let me show you what you can do to kind of take it to the next level, what Cypress facilitates and allows for. What we are going to do is we are going to, skip this test. We're going to perform this test, but we're going to do something a little bit different. Instead of waiting for this request to come through, we are going to actually mock a real network request from the perspective of your application under test. We are going to, when the user searches for Devon Becker, we are going to return me instead, John Hill. This is the, remember we looked at what that JSON object looked like. We're also going to do something. We are going to change the little avatar that's returned. And I just found a random one online. So what this, let's go ahead and give this a shot. We're basically intercepting and then manipulating the network request from the perspective of the browser and your application under test. So John Hill returned this result. And that's because I wrote the test in such a way that it could. But from the perspective of the application under test, this doesn't exist. If I were to open up, um, this and search for it, nothing would be returned. So this is great. So this takes it beyond just getting past flake. This takes it beyond just performance issues. And this really fundamentally alters how we test. This kind of gives us, for the first time, new capabilities to mock and stub real end-to-end tests. And it's something that my team has really started to leverage very recently to kind of change how we do everything from UI testing. So I actually won't go too far over the cons here. I will spend just another minute talking about getting rid of flake and what that kind of means. So we had an old Selenium-based JavaScript framework called Nightwatch, and one out of I think it was one out of every 2,000 or 1,000 runs, we would randomly have this failure occur in which a user could not log in. We had all of the testability we needed. We had videos, we had screenshots, we had records, we had everything that we needed to prove that, hey, we think something's wrong here, but we could never pinpoint it. We spent years and years working on this until, I closed it in January saying, this will forever remain a mystery. Well, we never figured out what was wrong. However, when we switched to Cypress, this is what we found. We found that out of every 1,000 login attempts, the actual server, the server itself, the thing that we're testing, responds with a 400 request. And here it is. It was unequivocal. For the first time, our tests became more stable than the application under test. For the first time, we knew that our test was working, but one out of every 1,000 times, a user couldn't log in initially. So that was really powerful, and that's really where, when my team saw the power of what we were doing here. So just to kind of summarize everything that we talked about today, the solutions that we're looking at here give us real browser interactions. They give us real-time information in ways that we never had before. There's fewer dependencies and less maintenance to worry about. It's still cross-browser. It's awesome. So let's talk about the future. So the future. We've added a new standard. So CDP is a new standard. It is not part of the W3C specification. We're propagating standards in a way that we never had before. The thing that Selenium never had to compete against was another open source tool. There was no competing standard. It was just closed source and the paid for product somewhere versus this collaborative open source project. Poor Firefox. I don't know what else to say there. Just to call this out, if you are going to do testing, if you are going to do cross-browser testing, it is important. But what we do is we use Per-C and Applitools to do that. And that's all, works natively with Cypress. So we have a separate test suite that runs all of our visual tests in all the different browsers. So if you are going to do cross-browser testing, from our experience, it seems to be better to, instead of running all your functional tests in every which way, run your visual tests. And just to take this full circle here, we talked about Sauce Labs and Browser Stack. They are now implementing Cypress with the different browser and platform compatibility. I just thought this was funny. We're kind of going full circle where we now have this new matrix to support, and these other hosting providers will do that for us. But the way I want to end this whole talk, the whole talk kind of comes to this. The powerful thing about Selenium is that your tests from 10 years ago probably still work. I don't know if you can say that for most things that you're working with in your toolkit. They're backwards compatible to a fault, and it will work 10 years in the future. That's really powerful. But they recognize, and what I want to bring up here, they recognize that times are changing, and the abstraction that they've added around cross-browser and the RESTful stateless interface isn't enough. So what you're looking at here is Selenium 4 in progress. And what Selenium is adding is a new bi-directional WebDriver interface that listens for DOM events, fails on JavaScript errors, intercepts requests and mocks the response, records the traffic, And it basically gives you most of the power that Puppeteer gives you. So effectively, more or less, there is going to be a new W3C specification for WebDriver that is equivalent to CDP in capability, and it will soon be part of the specification. And whenever this happens, it happens. Selenium 4 was supposed to come out Chinese New Year 2019. It still says, you can see the development here. You can track it here if you'd like. It is an open source project. But I think that best illustrates kind of the power of what we just looked at in this. Cypress, Puppeteer, and Playwright all add this new functionality that Selenium needs to continue. And if Selenium did not implement these things, I really don't see a reason to continue to stick with it. So in summary, we talked about Selenium, we talked about browsers, we talked about how they work to some extent. We talked about the problems inherent in Selenium. We rode the wave and how that led to the solutions that we have today with Puppeteer and Playwright and Cypress. We walked through 3 different frameworks and the test, I think, worked all the way through. And we ended with what happens next. And that's all I got.
Wonderful. Thank you so much, John. I think we can now go to Slido. If you just go to the Slido link, which we have given it in the chat. John?
Yes, just on the chat.
Zoom chat. Yeah, it'll be in the Zoom chat. Yeah. That's a good amount of questions. You can go ahead, John. I think you're on mute. Sorry.
Okay. Yeah. Thank you. Yeah. So the first one is, if you have been assigned to create a test automation framework from scratch, which framework would you recommend for beginners? So something I didn't have a chance to talk about, we had that opportunity. So cutting room floor. Just think about where you spend your time. So just if you have a framework today and you had to start from scratch, these are kind of how we prioritize what to work with. Cypress has great API documentation, the best that I've worked with. We were able to get up and running very quickly, but at the end of the day, we spend most of our time looking at failures. And I can show you our dashboard since we're an open source project. We do have failures, but in our case, they're actually legitimate failures. The application changed in our case, and this dashboard makes it so easy to see what happens. You get the logs. You don't have to dive into Jenkins. You get the screenshot stored and associated. So in our case, this test changed. Last night, a developer changed this and it broke the test. The test worked. We have a video of it changing. You can download that video and share it with folks. You can link directly to the URL. You can link directly to, you basically have everything you would want to have. You can see the individual commit that broke it. You can see the commit that broke that thing. So it's fantastic. You can, if you spend your time as a test automation engineer, a lot of your time is analyzing failures, and there's no faster way of doing that than using the Cypress dashboard. So ultimately, that's kind of what made the decision for us. We did a proof of concept between 3 different frameworks: Nightwatch, Puppeteer with Jest, and Cypress. And Cypress was the clear leader for writing new tests. That was for us. Let's look at the Slido. Test Cafe. I have not used Test Cafe, but I hear it's great. It's also, I think, a little bit proprietary. I don't know if it uses CDP or Puppeteer under the hood, but I've heard good things. I would say, play around with it. I've heard that the API documentation is really good, but I haven't used it myself. So is Puppeteer an alternate? Puppeteer is a direct alternative to Selenium. And in that demo that I showed, WebDriver actually hid all of the changes underneath of switching between WebDriver and Puppeteer. And your tests don't have to change if you're using WebDriver, for example. If you rolled your own framework, you're going to have to do some lifting, but they're very similar. I use WebDriver IO. How hard is it to migrate? So Cypress WIO. If you're trying to migrate Cypress plugins, if you go here and you look at the plugin docs, where is it? There's a list of plugins here, curated list, WDIO. Yeah, use this. It's called Cyphel. It helps you just port tests over. Intuit, the people that own and manage all of our money, they moved, and this is how they did it. Let me put that in. Here's the response. That's Cyphel. So if you want to move from WebDriver, use that. Let's see. My web desktop or Chromium, but mobile users are Safari. Which is the best choice if you only have one? So Appium uses the WebDriver API. And so your best bet might actually be something with WebDriver. WebDriver works really well with mobile. It's not something that I've ever had to work with, and that I wish I had, but I would consider using that. WebDriver IO specifically to use Appium to drive Safari on a iOS simulator. Let's see. Was it similar to Karate UI? Oh, I'm not sure. I've not used Karate UI automation. Is there a built-in support for reporting? Yeah, reporting is really great. Email is really great. The test framework, test data management, awesome. So all of the mocked responses we have in our test suite are in a fixtures file, and it does some really cool intelligent locating to find the fixture that you need if you are going to mock responses. We haven't used the page object model before, but members of my team have used that previously on other projects with Cypress. You can use it. We are going to just go ahead without it. Our tests themselves are going to be open sourced next month, November, and you can take a look at them. But we kind of just go with this raw Git action syntax. We do something, we perform an action. We do something, we click, and we do a lot to make sure that we have really good locators. So that's what we're doing now. Let's see. Can you explain network idle feature a bit more? Yeah. So if you want to look at it, playwright network idle. Yeah. So it's pretty cool. It's more than what I just showed. Let's see. Where is it? Playwright network idle. Let's see if I can find it. So what this does is this, so I don't want to spend too much more time, but it will actually navigate to a page, and it will, so let me pull up the thing we were looking at earlier. So if you were to pull up Chrome, I'm sorry, I'm not gonna be able to find it. But yeah, all those network requests are network traffic. And so with Playwright, it's actually, or Puppeteer, both of them work the same. You can say that when you navigate to our URL, instead of waiting for the DOM event for page loaded to fire, you want to wait for that and any XHR request that's going through. It's super awesome. I really wish that, I really wish Cypress had that actually. Yeah, so you can see here, you're basically instead of waiting for the DOM to load like Cypress does, you're actually waiting for all the XHR requests to stop. Let's see. Did I lose Slido? I did. Okay. Can you explain? Yep. Does Cypress support? Yeah, Angular. Yep, it does. No reason that it wouldn't. All the Angularisms that you would get with, oh boy, what's the name of that framework? The Angular framework. I can't remember it. All the Angularisms that you would get, you don't get with Cypress, but I mean, my team is actually moving from Angular to React. And so we had an opportunity to throw away our old test suite. And we've actually gone back and added old tests, or added tests to the old UI with Cypress, and it works. We have an application using a map. I have no idea. This is a good question. I would, if you're not already, I would join the Slack user group. That's part of this meetup group. Actually, let me not load my work Slack just in case something's on it. But yeah, so join Slack and ask that question. I'm sure somebody else has. And I think Mary will be able to share that. Playwright is faster. Depends. So Playwright is lighter weight. Yeah, when you download it, it is, and it can be a little faster. But if your job is looking at nightly failures, it's not faster. Like if you look at what you do with your time, analyzing results, writing tests, it's not faster. It'll run quicker, maybe. The parallelization model may be a little bit quicker, but if you're using the dashboard service, you can see we're running ours on 2 machines, and it does this really cool thing with test load balancing. So we are functionally limited by the number of CI machines we're throwing at it. It takes all of the tests, looks at the historical runtime, and then divvies up the tests in a way that makes it so that you're always ending tests or parallel work streams with intelligent test load balancing. So this one ended just a little bit after this one, but you'll never have a thread here that takes an extra 30 minutes if you would just did a stupid or an unintelligent parallelization model. It's pretty awesome, and it gives you this. If we wanted to throw more CI resources, our runtime could go from 53 minutes all the way down to 5 minutes if we wanted to, which is pretty awesome. Which reporting tool do you prefer with Cypress and why? We just kind of use the XML, and we use the dashboard. The dashboard is enough. Like the dashboard does everything. It has all these analytics that we actually use. Like we actually use this. So like we had a really big initiative to find all the flaky tests this summer before they added the flaky test functionality. And you could see we did it, and then we stopped doing it. And so our tests started to get red again as we were adding more features and everything was coming in. Again, if you're spending your time writing tests and understanding failures, there's no better way of doing it than using this. I mean, this shows you literally the error. It shows you the test. It shows you it running, and it shows you the screenshot. I mean, there's nothing more that you could want as a test automation engineer. Where should we keep looking in order to get it when you should mention? Oh, just follow Ansible AWX. We're going to put them in here once we open source the new UI. You can see it. We have an open source project here. This is what we're testing. I'll include that in the link. And you'll see it. We won't make it a big announcement or anything because they're just tests. But yeah, just follow this. And I guess if you want, I'll put them in the the Slack group. I'll announce when we move them. Okay, let's see. Oh, the GitHub. Yeah, life after Selenium. I'll also include it when we with the thing. I'll put that in here, and then in the Slido. Oh yeah. I've heard really good things. This is really pretty looking too. So like, if you want to report it to the dev team or managers specifically, it makes it look really good. Especially if you got a lot of failures, it makes failures look really good. Cool. Yeah. I guess if you have any more questions, I'm in the Slack. So just come to the Cypress Slack, and we'll talk about it in there. Cool.
Good. Thank you so much, John. It was really, a great session. I think there is one question which is, okay. They're asking you to share the code in GitHub if possible.
Sure. Yeah, that's here. That's the life after Selenium, and I put it here as well.
Oh, excellent. All right. Okay. Wonderful. So is there anything else that is there in the chat? No. Thank you, John. Thank you so much. It was indeed a great session from you. And thanks everyone for joining. And, I hope we will be able to meet in the next session. Mary, do you have anything?
Just quickly, because I think someone asked for the Slack channel for our Cypress UK group. So I've pasted the invite link into the chat. So feel free to to join our Slack channel. There's like different channels where you can ask like specific questions, and it might be useful as well for some.
Wonderful. Thank you so much, Mary. Thanks, folks. Thank you so much. Have a good day or have a good evening. Speak
Thank
soon. Take
you.
care. Bye.
All right,
Bye.
thanks everybody.
Bye.
Thanks, John.
Bye-bye.
Bye.
Yep.
Bye.